The machine we're going to be using in the demonstration today is actually a ShopSabre Pro 408. 408 simply means 4 foot by 8 foot. Pro means production. You know, people ask me all the time, how do you really judge these machines? I said, well, it's really simple. Here's where I start. I start at the base, and I look at how the base is structured. These machines are all welded. It's structural steel. It's made in USA steel. So I think if you start with quality components, that creates a great basis, and that's how we've done these. Now, the other parts of the frame are actually the gantry, and once again, these gantries are tubular steel, all welded, and we also have tubular steel supports. So those are the 4 frame parts. Now let's talk about what makes all this stuff move, and it's called motion control. The first part of machine motion is actually defining the axis of travel, and here's how we do that. These are actually precision contour guide rails, and you'll find those in all 3 axes. We get asked sometimes, how do you determine what this spacing is? Well, we use a process for engineering called finite element analysis, and that basically tells us where to space those to get the maximum support for the cutter in the material. That's why these machines cut so well. All right, now, what actually moves the machine around are the ball screws, and these machines are all ball screw machines, so that means we have precision ball screws in X, Y, and Z axis. And you know, the application that we're doing is really critical for accuracy. So let's stop a minute and let's talk about how this whole ball screw thing fits in. The application we're doing today is probably one of the most difficult ones to do in wood. And here's why. We're creating MDF tool paths, and what those are trying to simulate is a look of a solid wood raised panel door. And we achieve that by using multiple tools. Now here's what gets really, really tricky. You have 3 tools that are side by side and slightly overlap, and they're all the same distance, and if one of them's off, you see a line. And the real challenge becomes also being able to maintain that relationship all over the table. And that's why we use ball screws. Now let's talk about that a little bit. The reason ball screws work is a concept called preload. Preload just simply means they're engineered so there's a 0 play, all right? So we don't have to worry about any play. If you contrast that with rack and pinion, you have to have backlash. Backlash is another word for play. So typically, the mesh between the pinion and the rack will have 3 to 5 thousandths play. And you have that on each end. And if they don't have that, the machine will hang up somewhere. And you think, well, that's not a big deal. Well, it is a big deal because somewhere on that sheet that you cut, that play shows up. So it might be in a corner of a door, you might have a line on one side. And that's why it makes so much sense to use ball screws. Now, even some of the larger manufacturers that offer machines with ball screw or with rack and pinion typically will not sell you a rack and pinion machine to do MDF doors because there's just too many problems with fits not working out right. Now, let's look at the next part of machine control, and that's machine control itself. The final part of machine motion is actually the machine control itself. And these machines have our ShopSabre MMP Control technology. MMP stands for Mitsubishi Motion Platform. And we selected that because it's a very robust system and it's rock solid. So we wanted to build the underlying structure of the control system on that. But there's another part of machine control that's really people related, and it's really how easy is it to use and how easy is it to teach someone to use. So we really focused on that part. And if you notice on our screen on the control, everything's displayed on one screen. So everything you need to do to run or set the machine up is there. You don't have to fumble around. And part of that is to make it much easier for the operator. Now, from an operational standpoint, all I really have to do is load a program. Then I click on this little icon, and it displays on the screen what the program is going to produce. Now, that's visual validation. So number one, I know what I'm going to cut, and the other part, it lets me kind of get an idea of where the parts are going to be on the table. When I'm happy with that, I simply hit the green button, which is the start button. The machine starts executing the program, and actually on the display over here you can see the exact live position of where the machine is. So it's a really, really simple, powerful control system. Now let's take a look at the machine spindle. This machine has a HSS spindle. This happens to be an ATC spindle. That means automatic tool change because the machine has that feature. We offer these in a number of different horsepower ratings based on what your machining applications are. But you know, here's an interesting part right here I always like to look at, because What we wanted to do was to increase the rigidity of the tool plate, because that allows us to have more axis travel. And to really get the maximum advantage of your machine, you have to have enough axis travel so that if you can get a part under the gantry, you can actually machine it. So that's really what started all this. So we plugged the data into our FEA system, and we tried 2 or 3 different ideas, and this one hit. You know, the results came back from that, and then we did some testing and cutting, and it really worked well. And then we said, okay, now we know mechanically how it works. Can we reduce the mass of these plates and get the same result? And once again, FEA was used for that. And now you see this feature on all of our machines. Well, we're talking about mass. So let's talk about another problem, and that is, think about mass of what's on this tool plate now, because of gravity, mass is weight. All right, so here's what happens. When you're raising the spindle up with the ball screw, you're lifting all that weight. When you're dropping it down, it goes down real easy. All right, well, there's an impact with that. Number one, it's going to probably make your ball screw wear out. But what we wanted to do is actually put a cylinder on here, a balancing cylinder that balanced the weight of that tool plate. So basically what it does is it neutralizes that weight. So the machine raises and lowers with the same amount of ease. Now, there's an impact of that you may not think about. In 3D machining, the slowest axis determines the true feed rate. And typically that's going to be the Z-axis. But because of this cylinder, now we've neutralized that weight. Our 3D machining is much, much faster. So that really worked out well. Now, let's take a look at the table on these machines. This machine actually has our vacuum table option. This one's phenolic. We also make them in a couple other materials. Also, you'll see the T-slots here. That's another option, and that gives you tremendous fixturing capability for really weird parts. So that's a real popular option. You know, when I look at the label on the machine, I see that 4, and I say, well, that must be a 4-foot wide machine. But when I measure the table, I find out something. It's bigger than that. It's actually 5 feet wide. And you say, well, why do you do that? Well, the reason we do it is because that extra travel lets us put other options over here, like different kinds of heads. But there's actually a side benefit that probably wasn't planned on, and that is because it's 5 feet wide, I can cut 5 by 5 Baltic birch panels. You know how many machines are purchased with bigger just because of that application? Our 408 machine takes care of that. So that's a huge benefit to me personally. Now, let's look at the vacuum system itself. What you see here are large ports. The secret to vacuum working well is efficient flow. So we start with those. Those are connected with hard tubes to the manifold, and we have valves on the front to control those. That manifold itself is an integral part of the machine frame. It's not an afterthought. And we included that when we actually designed the base frame. Now, from the main manifold, then, there's a 4-foot tube that goes all the way to the back. So what happens with all that flow, these machines really hold parts well. I think that's a huge benefit. Well, we've looked at the machine itself. Now let's go take a look at the software. Let's take a look at this concept of MDF tool pathing. Let's dig into it a little bit to see what we're trying to do. About 20 years ago, this whole concept was created about the time nesting began to be popular. And the idea was we wanted to create doors or other things out of MDF that actually look like a solid raised panel door. Now let's dig into that a little bit. What you see on the screen here is actually a model of a typical solid wood raised panel door. This would be called a 5-piece door because it's got 2 stiles, 2 rails, and a panel. Let's turn some of this off so we can look a little closer. And we'll hide that, and what we have left is what's called a stile. Stiles are the upright members, and this molding that you see on the inside here is called a sticking, all right? Now, let's look at something else. Let's get rid of this in the panel, and let's look at what you see down here. And the molding on the end of the rails is called a cope. So you had a tool set called a cope and stick, and that's how all this came about. And then, of course, the panel actually floated inside of those grooves. So that's where the concept was. What we were trying to do was with tools at MDF create that look in a cabinet. And it became very, very popular, primarily when white cabinets became popular because you could actually paint that. And MDF was a tremendous material to machine out of. And so that's where this all came about. And there were some people that actually cut these doors out and foiled them. different ways to add adornment to them. In our case, we would typically paint the cabinet white. So that's what we're trying to actually duplicate. Now let's take a look at the tools that are required now in order to create that effect on an MDF panel. Now let's take a look at what we have to do with tool paths to create that raised panel effect on the MDF panels. Well, we start out up here and you'll see that there's a sample here. Let's zoom in on that a little bit. Now this is a piece of MDF material and you see the first tool path cuts a dished out area. We call that the panel cut, all right? And you'll see how this shape comes about. We'll zoom back out. Let's look at the next one. Now the next one is called a bead cut and it actually creates that bead effect. And actually, you can see now that's pretty much what the cross section of a raised panel structure looks like. Now, there's a couple other tool paths also that we actually use because we want to tighten up the corners. Now, you don't see it on here, but the shape is the same as the bead. It's just a very small tip, so it goes much tighter into a corner. And then the last pass actually is the same tool, but up here at the top, and that's how you get the corner that looks like a really nice raised panel structure. So those are tools that are required to actually create this MDF surface. Now let's actually look at the physical tools themselves. What you see on the table is actually a set of tools from our friends over at Vortex Tool. And these are actually tools made specifically for this application. And the tools that you see here are actually called insert tools. And what that means is they have cutting inserts. And when they get dull, you only purchase the insert. So it's a really economical way for tooling if you're going to do MDF tool pathing. Now let's take a look at each one. This is actually that first one that I showed in the simulation. That's the panel tool. Okay, and then this one is the bead tool. It created the bead. And then this last tool was actually what we call a cleanup tool. So it's actually used twice, down at the panel level and up at the top of the bead level. And that gives us the actual much tighter square corners. All right, now let's go to the next level and let's see what it takes to actually create the tool paths we're going to need to use these tools. Cabinet design softwares like Mozaik actually incorporated MDF doors into their basic programs. And let me give you an example of how that works. So think about it, if you're actually doing a kitchen, you'll have certain designs that you like, and they're actually in a library. Let's take a look at that. It's in the door library, and you can have any number you want, really. There's a typical one pass. You see that's a drawer front. There's a raised panel. And so basically you can actually create custom ones too, and those then become doors in your library. And so you basically tell the program what you want to use. Now let's carry this forward, and I'll show you a complete job here. Here's a sample kitchen. If you notice, you'll see the doors on here. These are the ones with a single arch at the top. These are rectangular. Once again, you can mix and match whatever you want in that. Now let's go to the next step. How do we actually make the doors? All right, we've got them designed. So what we'll do is close this. We'll go over to the cut list. That gets us to the optimizer. And we'll just optimize to 3/4 MDF because that's what the doors are made out of. We'll overwrite the last job I ran. Now what it's doing is it's actually going through and it's creating all those parts. And it's going to give us the opportunity here to actually optimize or nest them on a sheet of material. And we'll hit that, and it's pretty fast. And basically it looks like 3 sheets of material, and I produce all those MDF doors for that job. So it's a really nice system, and then all I have to do when I get to this point is hit generate G-code, and it creates the programs to run on the machine. And that's automatic. Once on the optimizer, I have the tool set up for MDF doors. So it's a really, really, really simple thing to do. But let's look at MDF doors from a little bit different perspective. One of the things I really like to show on some of these videos is things that maybe you hadn't considered that the machine has the capability to do. And MDF doors are a great example. Now, we've already looked at how MDF doors on typical cabinet jobs work, but there's another scenario here. Let's say that, for instance, maybe a local shop finds out you got a machine and all that stuff and that you can make MDF doors, and they come over and they say, would you make some doors for me? And you say, absolutely. And what do you really need? I need to know what the style is, what the size is, and what the quantity. That's really all I have to know. But you know, I don't have to do that in the front office. I can actually do that at the machine because the ShopSabre MMP controller actually has a Windows interface. Therefore, I can run the Mozaik software out there. What does that mean? That means I can give my machine operator that order. They can actually process it right there at the machine, cut the doors, get them ready to ship. I don't even have to be involved in the front office with the software. So it's a new way of looking at things. And now let's actually go out to the machine and let's actually use that software on the machine control and cut a nest of these doors. I actually wanted to drive the machining demonstration in this video from a concept we call the door factory. And here's how this works. First off, because the ShopSabre MMP machine control has a Windows interface, that allows me to run the Mozaik software actually on the machine control. All right, how does that relate to the operator? Well, first off, the operator gets a list of the doors for the job. So that's going to be a certain style door, it's going to be a certain size. All right, now Mozaik has an order entry system, and we'll take a look at it right here. And if I look in order entry, there's actually, as part of the catalogs and sub-assemblies, there's actually doors. So I can click on that, drag it up here, and then my operator just simply types in the sizes and the quantity. And that's how we schedule a production run, okay? Now let's go to the manufacturing part of that, and that's the optimization. So what we do in optimization, here's what the job looks like. Here's all our parts. We go to optimize. Optimize is another word for nesting. And let's look at our patterns. Okay, so it looks like for that order it's going to take 2 sheets of material. We'll run this one because that's a pretty nice nest. Now that's what the nest is going to look like. All I have to do is hit generate G-code, send the file to the machine control, and we can run that. Let's do that right now. Well, our MDF door project came out really, really good. The doors are magnificent, the corners are perfect, this area is perfect. Most people don't realize how difficult this application is. It's probably the most demanding application in woodworking, and let me tell you why. The way we create this effective erase panel door is actually multiple tools, and 3 of those tools have to be set at exactly the same depth, and they're adjacent to each other. So if there's any variation, you see a line there. And on this, anywhere on the table, it's perfect. There are no lines. By the same token, when you start looking at the corners, they're all perfect and they're all consistent. That's what you get, first off, with a really good all-welded frame, but more importantly, a ball screw system. If you try to do this with rack and pinion, here's what's going to happen to you. All right, rack and pinions have backlash, and backlash is another word for play. So you have 3 to 5 thousandths on each end, and sometimes that works fine, but sometimes it doesn't. Somewhere on that table, that play is going to show up, and you're going to see a defect in the door. We don't have that problem on a ShopSabre because we use ball screws. That's why these came out so well. Well, I hope you enjoyed the video. We had a great time producing it. If you have any questions, you can contact us at shopsabre.com. Thank you for watching.